Hey everyone, it's Justin again. In this video, we're going to learn about the distributive property and how we can use it to simplify expressions. We'll complete 4 example problems together throughout this video. Have you ever heard the word distribute? What does it make you think of? Distribute just means to give something out equally. Like at a party, you might distribute a pizza to your guests so that everyone gets a slice. When we talk about distributing in math, there unfortunately won't be any pizza involved, but we are still talking about giving something out equally. Take a look at this expression, for example. 3 times the quantity of 2 plus 5. We know that using the order of operations, we would do 2 plus 5 to make 7, and then do 3 times 7 to get 21. And that works great. But there is another way we can do this. Since the 3 is being multiplied times the whole grouping, we could treat this just like a pizza party. Except in this case, the pizza is a 3. I can distribute it to each of the terms in my grouping to get 3 times 2 times 3 plus 5. If you calculate this down, does it still make 21? We get 6 plus 15, which is indeed still 21. So we know that doing the multiplication this way is equivalent. So why do we need another method when combining the 2 and the 5 inside the grouping just works perfectly fine? Well, what if instead of a 5, it was an x? I can't do 2 plus x because they're not like terms. But I could still distribute my ooey gooey cheesy pizza 3 to the 2 and to the x. Now that we have some context, let's actually start to define what the distributive property means in math. There are 2 scenarios where the distributive property applies in math, and the first is with multiplication. At its core, the distributive property of multiplication says that if you have a grouping that is being multiplied by something, you can distribute that factor and multiply each term from the grouping separately. It can also be used if you have more than 2 terms in the grouping. You would just distribute the multiplication to all of the terms. You can also use subtraction in the grouping too. What's most important is that you keep the same operations from the original grouping when you distribute. Let's do 2 example problems together to see what this looks like in action. This problem says to distribute the multiplication in 4 times the quantity of 3x squared plus 9y minus 7. There are 3 terms inside this grouping, so when we distribute that 4, we have to make sure that it goes to all 3. Just like if our 4 was pizza, we don't want anyone left out. So pause the video now and give this one a try on your own. When I distribute, I like to make a mark or annotate my problem to show myself where I've distributed and to stay organized. I know that 4 has to get multiplied by every term here, so I'll start by doing 4 times the first term, 3x squared. Next, I'll bring down the addition sign and then multiply 4 times 9y. My next operation is subtraction, so I'll bring that down, and then I'll multiply 4 times the last term, which is 7. Now I do actually need to multiply all of these. When you multiply a constant times a variable term, you only multiply times the coefficient. So when I do 4 times 3x squared, I just do 4 times 3 to get 12, and the variable won't change at all. So it will still be x squared. Why do you think that is? Remember, a coefficient just tells us how many of something we have. So 3x squared means that I have 3x squareds. Multiplying by 4 means now I have 4 sets of 3x squareds. So I now have 12 total, but the thing that I'm counting here hasn't changed. It's just a bigger group of x squareds than I started with. If you hadn't started multiplying yet, pause here, and finish multiplying the other two terms. With 4 times 9y, 4 times 9 makes 36, and the y stays the same, so we get 36y. The last term is just a constant, so 4 times 7 makes 28. This whole expression, 12x squared plus 36y minus 28, is our final answer. Let's do one more problem like this. This next problem also says to distribute the multiplication. I see that we are distributing a negative number here. That doesn't change anything, but just be extra careful about your signs. Pause the video here and try this one on your own. I need to distribute the negative 2 to both terms in the parentheses. That means I need to do negative 2 times 5m, then I'll bring down the subtraction so I don't lose track of it, and then I'll do negative 2 times 3p. Notice that I put my negative 2 in parentheses here too, so that I didn't get confused with the minus and the negative next to each other. For negative 2 times 5m, I multiply negative 2 times 5 to get negative 10, and then the m stays the same. I'll bring down that subtraction because I want to be careful it doesn't get lost, and then I can do negative 2 times 3p. Multiplying the coefficient gives me negative 6, and the p just comes along with it. I put my product in parentheses to help me keep track of that negative, but having minus a negative here is correct, but it's not great math grammar. Can you think of a better way to write minus negative 6p? Yeah, instead of minus a negative, we could just write this as plus 6p. Now that is a nice looking final answer. As you get more comfortable with distribution, you may not have to write all of this scratch work. You might even start to notice things like how we could have considered this as negative 2 times negative 3p and have gotten that coefficient of positive 6 from the start. So we've seen that, like pizza, we can distribute multiplication to a grouping. But there is also a distributive property of division too. Try using some context clues. Knowing what the distributive property of multiplication does, what do you think the distributive property of division says we can do when we have a group that's being divided by something? Yep, I'm going to take each of these terms from the numerator, separate them out, and divide them each by the denominator. And just like with multiplication, there can be any number of terms in this grouping. We're not just limited to 2. Let's try it out. This problem says to distribute the division. We have a fraction with 3 terms in the numerator, and they're all being divided by negative 3. I know that 18w squared has to get divided by negative 3, so I'll write that as a fraction as its own term. Then 21n squared has to get divided by negative 3, and the operation here is subtraction. So when I write it as its own fraction, that becomes minus 21n squared over negative 3. And for my last term, it's being added, so that will look like plus 6k squared over negative 3. Just like I did with multiplication, I only have to worry about dividing the coefficients by negative 3. The variables will stay just the way they are. Pause the video here and try finishing this division on your own. (18) divided by negative 3 makes negative 6, so this becomes negative 6w squared. It can help make your work easier if you consider the operation before a term like a sign. So for my middle term, I can think of this as minus, or negative 21, divided by negative 3, which gives me an answer of positive 7n squared. And that positive sign becomes our operation as a plus sign. And for the final term, plus, or positive 6, divided by negative 3 is negative 2. We could do the same thing here, where the negative result of our division can be shown with a minus sign, making this minus 2k squared. If you didn't notice that you could use the operations as positive and negative signs, you may have wound up with an answer like this. Having a minus or negative or plus a negative is bad math grammar, so you can just adjust and simplify your signs in your final answer. No matter how you like to consider your signs, you should still wind up with the same final answer. Let's do one more together. This final example problem also asks us to distribute the division. There are 4 terms in the numerator this time. Do you think it matters that there are more terms? Nope. We could have 100 terms and we would still use the distributive property the same exact way. We just have to make sure that every term gets divided by 2. Pause the video here and try to do this whole problem on your own. When you distribute that division, you should get 14a over 2 plus 9b over 2 minus 8c over 2 minus 2d over 2. Because we just break out each term from the numerator and put it over 2 by itself. Next, we can do our division. 14a divided by 2 makes 7a. 9b divided by 2 makes... 9 divided by 2 does not make a whole number. So what do you think we do? Yeah, this is totally okay. We could just make our coefficient the fraction 9 over 2. Just like with a whole number coefficient, the entire 9 over 2 fraction can go in front of the b. Next up, minus 8c divided by 2 makes minus 4c. And lastly, minus 2d divided by 2 makes minus 1d. Do I have to write the 1 in front of 1d? No, we know that 1d is the same as just d, so we can also leave the coefficient off if we want. And now that we've divided everything we can, this is our final answer. Distribution is a really important skill to have, and it will come up a lot in your math courses. Make sure that you apply your multiplication or division to every term in the grouping. After all, just like at a party, you don't want anyone to miss out on getting their ooey gooey cheesy slice of pizza. Now that we're done with our lesson video, make sure your guided notes are complete, and then you can move on to the practice game. Meanwhile, I'm off to go find some pizza. I have the strangest craving for it. Anyway, good luck, and I'll see you next time.